Now let us see what are isomers. Let us start with the Lewis dot structure of a hydrocarbon, which is C4H10. So C4H10, how many valence electron will be there total? Let's see. Carbon is in the 14th group, so 4 valence electron. We have 4 carbon atoms, so 4 times 4, 16. And hydrogen is in the first group, so 1 valence electron, and we have 10 of them, so total 10 for hydrogen. So when you add these two, we will have 26. So how many pairs will be there? 13 pairs of electrons will be there. So that is the beginning or the starting point of drawing a Lewis dot structure. So for a hydrocarbon, we can actually connect all the carbon first. So carbon 1, 2, 3, and 4, because we have 4 carbon atoms in the molecule, right? So we will connect that one with a single bond here, one line. One line means 2 electron single bond. And then each carbon will have 4 bonds around it because the valence electron for carbon is 4. So we will draw 4 lines around, that is single bond around each carbon. And we can actually write hydrogen, and hydrogen need only 2 electrons to satisfy, and that means it is a duet. So in this case, we are getting a valid Lewis dot structure here. Okay, so now, is there any other way? So let us count 13 pairs are there or not. So we counted 4 here, right? 1, 2, 3, 4, and 5, 6, 7, 8, 9, 10, 11, 12, and 13. Okay, so that is good. So is there any other way we can actually arrange these 13 pairs of electron and to get a valid Lewis dot structure for C4H10? I'm going to try another one. So let me grab. Okay, so I'm going to try carbon, single bond, carbon, single bond, carbon, single bond, carbon. And now I can see that this carbon is connected to 3 other carbon directly, whereas in this case, each carbon I can say is connected to another carbon only, correct? C to C only. Whereas in this case, I can see one carbon is connected to 3 other carbon, the center one, whereas at the edge, you can see it is connected to only one of the other carbon. So now I will satisfy each carbon with a 4 bonds. 4, 1, 2, 3 already. So 1 here, 1 here, now 1, 2, 3. And now I will put hydrogen around this one. I can see that, oh, okay, here. 1, 2, and 3. So we have 3 plus 2, 5. 5 plus 2, 7. 7 plus 3, 10 hydrogen and 4 carbon. And 13 pairs are there. Let's see 13 pairs. So for counting, I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 pairs are there. So this is also a valid Lewis dot structure. So we have 2 valid Lewis dot structure for the same molecule C4H10. But we can see that the connection between the atoms is a little different. So in this case, as I said, C connected to another C only. Each carbon atom is like that. Whereas in the second one, this is first one and this is second one. So in the second one, we can see one of the carbon atom is connected to 3 other carbon atom, right? So these two structures are different, and we can say that they shows different properties, so they are different molecules. We will learn more about this one after learning the naming and other functional groups and all. So you can see that these two molecules behave different. The properties are different. So let's try one more and then we can go ahead and see. This example is C2H6O. So you can see here 4 plus 4 for valence electrons for carbon, 4, 4, 6 hydrogen, and 6 valence electron for oxygen. So total 20 electrons. So we can count 10 pairs. And now in this case also, we have carbon 1, carbon 2, 1 oxygen, and 1 hydrogen. and each carbon 4 bonds around it. So we have to add hydrogen, hydrogen, hydrogen. If it is not there, it means that is hydrogen. Okay, so we can write actually simply just by showing the bonds around carbon. So if nothing is there, that means it is hydrogen. So we have 6 hydrogen, 1, 2, 3, 4, 5, 6. Of course, we got the structure 1. And you can see that here oxygen is bonded to one of the hydrogen and another carbon here. In this case, you can see the second structure. We have 2 carbon and how many hydrogen? 1, 2, 3, 4, 5, and 6. And we have 1 oxygen. In this case, we can say oxygen is bonded to 2 other carbon atoms. So that means the structure is different, the bonding is, the atom it is bonded is also different. So that means these two are different molecules with the different properties, right? So different structural formula, but the same molecular formula, correct? So that's how some of the molecule shows in the Lewis dot structure. So we call that one as isomers. So that's the same example here. You can see the name is different and we will learn more about the naming and the properties later. So now try to understand that the elements are connected to different elements here and here too, different atoms, correct? Okay, so they are called isomers. Same molecular formula, but different molecules, different structures and different molecules. So these two compounds are called isomers. So the definition is isomers are molecules with the same molecular formula but different Lewis dot structure or structural formula. That means they are different molecules. Here is another example. We can see that in this case, carbon 1, carbon 2. So there are 2 carbon atoms here and 4 hydrogen. We can say 1, 2, 3, 4 hydrogen and 2 chlorine, 1, 2 chlorine. Okay, so you can count the number of valence electron, 13 pairs. Again, this is repeating for some reason, right? Okay, so here 13 pairs you can see, and it can be also arranged in a different way. So here the chlorine is attached to the same carbon. You can see that one, right? Whereas in this case, I will show you like this. Okay, so then in this case, where chlorine is attached to one carbon on this side. So that is actually showing a difference in the arrangement of atoms, right? So the structural formula is different, but the molecular formula is same. So these two are different molecules. So we call it as isomers. They're all in 3D structure, okay, even though we can draw on the paper as a 2D model, but it actually, as you know, if there are 4 bonds around the carbon, we call it as tetrahedral shape. Tetrahedral shape. For each carbon it is tetrahedral, and one of them will be projecting out from the page and one of them will be behind the page. So you know that tetrahedral shape. So even though in the paper we show this one as 2D model, okay, so don't get confused just by drawing, say for example, the same thing some people may draw C, okay, and connect the chlorine here and connect hydrogen here, and in this case, just connect chlorine here, and hydrogen here, and hydrogen here. This is an isomer. Don't think like that, because even though it is just drawn in different way, like this direction and this one is this direction, that doesn't mean it is isomer. Okay, it is not an isomer. So how can you identify an isomer is by looking which are the atoms it is connected to. So that's what you have to look for. Okay, so just pay attention to that one, and also make sure the molecular formula is same for both the structures you are drawing, or both, maybe more than 2, more than 3, right? So it depends on how many are there. So please pay attention to that as well. And another example is C3H8O. So again, we have to calculate. Again, it is coming 13 pairs, right? Okay, so here we can see the isomers. I have 1, 2, and 3 isomers for this molecule. So let us see what's the difference. So this carbon 6, or carbon number, Okay, the number is written as 4. Let us take it as 4. Or that's okay. So this is the part I'm talking about. Okay, this part and this part. So carbon connected to oxygen connected to hydrogen. And in this case, carbon connected to oxygen connected to carbon. So this is different from the first one. And in this case, carbon connected to oxygen connected to carbon. So that's why these two structures are same. Okay, that's why I put O here. So that means the atoms are connected to the same. See that? So there is no difference between this structure and this structure. Okay, so here in the third one, I can see that one of the carbon is connected to oxygen and hydrogen. And this oxygen is connected to hydrogen. So this carbon, in this case, maybe you are thinking this is also connected to carbon, oxygen, and hydrogen. Of course, carbon, oxygen, and hydrogen. But that carbon is connected to another carbon, right? And another hydrogen here, another hydrogen here. So that means this carbon is connected to another carbon and another carbon. So this carbon is different. So this is surrounded by two hydrogen and one carbon, whereas this carbon is surrounded by another carbon, and another hydrogen. So that is why this is an isomer of C3H8. Oh, this is also an isomer. So because this part is different here. Whereas in this case, this part is different. Okay. So that's the reason. So we have three isomers in this case. All right. I hope you have an idea about isomers now. So pay attention to the atoms it is connected to. Just not because of it is bending, it cannot. Okay. So they will give, by drawing different structure, you should have different molecule and they are connected to different atoms. One more example, which is C3H6. In this case, how many valence electrons? So 3 times 4 plus 6, 18. So that means 9 pairs. Okay, so we can put carbon 1, carbon 2, carbon 3, and we took 1, 2, 3 pairs already. How do you know that one is? Okay, let me show you from beginning. C, I will connect just C, 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 3 carbon, and I will see 6 hydrogen. So I can put 1, 2, 3, 4, 5, 6, correct? And 6 hydrogen. So I don't have another place to put hydrogen. I don't have another hydrogen to put on this carbon. So, and this carbon number 1 got all 4 bonds, carbon number 2 got only 2 bonds, and carbon number 3 got 4. So how can you make the second one with a 4? That's what we will think now. So what we will do is we will transfer one of the bond to this one. That means there was a hydrogen in the beginning. We put, right? So then we will shift that one. So that means 1, 2, 3, C, and then C double bond, and here C. So now this carbon need only 2 hydrogen, and this carbon we will give another hydrogen. That's how we are drawing the Lewis dot for C3H6. So 1, 2, 3, 4, 5, 6. Okay, so there will be a double bond. Whenever there is a double bond, another possibility of drawing this molecule will be a cyclic one. You see that? 1, 2, 3. So 3 carbon atoms are connected in a cyclic way. And then we will put the hydrogen to satisfy the bond for 4 bonds for each carbon. So that will also give you C3H6, or total 2 isomers for this molecule.